theory. And then we're going to do the quantum numbers today. Yeah, how long are you going to have it? I wasn't using it or anything. All right, everybody got their notes? All right, so we have to talk about two scientists that you may see on the exam, or you may not.
So my folder head broke right here.
Yeah.
So I took these papers out. The stapler, I did not take these, so these are not coming out. That's fine.
Okay.
I don't need them anymore.
Yes. That's brilliant, Annabelle.
I know.
All right, so we're going to talk about Bohr's theory. Now, Bohr is the guy with the ring on the back of your orange chart. Okay? Now, I will tell you that most of his theory is wrong, but not fortunately for us, he's a nice precursor to the theory that's correct. So, if you guys built Bohr models, and I'll draw a Bohr model for you here shortly, we still teach him because a lot of what he did say is a nice, like I said, precursor for what is used today, and it is correct. Now, Bohr said that electrons circle the nucleus in fixed energy rings called orbits. All right? Now, Bohr called these things orbits. So, when you guys were in middle school, maybe you built things that looked like this. Maybe your teachers taught you how many electrons could go on each of the rings.
That's what I'm gonna be honest. I look like a solar system.
That's what I thought you were drawing.
A lot of teachers will teach it and call it a planetary model. There's a lot of similarities to the way it looks to a planetary model. But that's Bohr's model, okay? So when you look at it and you see the similarities to that, all right, it's often referred to as the planetary model. There's nothing wrong with seeing it that way, all right? But those rings are referred to as orbits, and they have fixed energy. Now, the problem with that model and those fixed orbits is it's not correct.
Then why are we learning about it?
Because we are. I still teach it in physical science. It is in the curriculum. Not only that, one of the reasons we still teach it is the number of electrons your teachers would have taught you that are in the rings are still correct. So there's nothing wrong with that part of it that they taught you. Okay? Oops. But I put a little X here because it's not correct. All right? Now, the second thing he said is that electrons can only move up and down between the orbits. Think of this as sort of like rungs on a ladder. All right? Can you stand between the rungs on a ladder? I don't know about y'all, but I can't hover between the rungs on a ladder, and it's not because I'm overweight. I couldn't do it when I was skinny. All right? I had to stand on the ladder, on the steps. It would be fabulous if I had the ability to hover between the rungs and could float in the air, but I do not have that ability. So what Bohr is saying is, when you built these Bohr models, where did you put the electrons if you did these types of models in middle school? They had to be where? On the rings or between the rings? On the rings.
When did we do these models in middle school? What grade?
Probably 8th grade.
Probably definitely. We learned about the water cycle and that was
Everybody always tells me that. I feel confident that y'all did something besides the water cycle.
No, like I swear that's all I remember. Yeah. We wrote a story on the water droplet.
Okay. That part is wrong also. Now, the part that he has correct is the third part. All right? Electrons closest to the nucleus are lowest in energy. So, in my model that I have drawn up here, all right, I have rings 1, 2, and 3. So, according to what Bohr said, which one of those would be lowest in energy? Right. Okay, so in the model that we have drawn, ring 1 has lowest energy, and ring 3 would have the highest energy.
So is this true for the
Yeah, highest out of those 3. Out of that particular model. Okay, that is the model for sodium, by the way. That's the atom I drew. What'd you say, Linda?
I was gonna ask you if that was true for all of them, but then you just said that was the model for sodium.
Yes. So if I had one that, let's say, had 5 rings, okay, the first ring would be the lowest, and the 5th ring would be the lowest. Highest.
Are we gonna have to know those type of numbers?
Huh?
Are we gonna have to know like which one's which?
Yeah, because we're gonna figure that out. We're just not there yet. You will be in a matter of days. Annabelle, get off your phone. All right, we caught up?
Yes.
All right, how about now? All right. So a man by the name of Erwin Schrödinger. All right. He's known as the father of modern quantum theorem. I spelled that wrong. Now, there's another guy in between by the name of de Broglie, and he came along and fixed some things in Bohr's model, but de Broglie's not going to be on the exam, so I'm just skipping over him altogether.
Right.
Okay? Now, he said, first of all, that electrons, let me see if I can match them up in order. What do I have first? Electrons can be found in orbitals.
And he was right.
Yep. Okay.
What are orbitals?
Now, orbitals are 3-dimensional areas of probability. All right. Now, to compare them with the pictures we just drew, they're not flat rings where the electrons must be found. All right, for example, right now, if Linda's mom showed up together, all right, for whatever reason, the office would look at the computer, they would check her schedule, they would know she's in chemistry room 29, and they'd call down here to get Linda out of class. Does Linda have to be in room 29? No, she could be in the bathroom, she could be in guidance, she could be in the office. There are any number of places Linda could be, but the greatest chance of finding Linda between 11 or 10 and 11:40 is where? In here, room 29. So an orbital is where you have the greatest chance of finding the electron. But does it have to be there? No. So when you see models of modern quantum theory that show orbitals, they don't show them as rings. They show them more as shaded areas that get darker in one area and less bright in another area to show the greatest area of probability. They're not shown as rings. Now, for number 2, all right, the electrons do not have to move to a ring. They can be found between orbitals. So in my example earlier, where I said the electrons could not be found between, like the steps on a ladder, we couldn't hover between steps, Schrodinger says that yes, they can. The electrons are not required to be on a ring. They can be between the rings. Okay? They're not required to be in between. All right? And number 3 is the same because it was correct. All right? They have the same energy. The further you get from the nucleus, the higher in the energy you are. So he did not alter that because he agreed with Bohr. It was correct.
So
Now, nothing that Schrodinger did has been proven wrong to this point. Okay? Many years later, his theory still stands. Now, Lasia.
Okay, I'm sorry.
All right. Everybody caught up?
Yes.
Now, aside from this research, the important part that comes out of Schrodinger's work for us today is Schrodinger wrote a mathematical equation describing the location of electrons in an atom. Okay? Now,
This is still under.
still under Irwin. So, not only did Irwin correct Bohr's theory, he wrote a mathematical equation describing the location of electrons in an atom. Now, in this mathematical equation come the 4 quantum numbers. Okay? Now, I'm not writing the equation on the board. It's long. It's in Greek letters. It'd fill the board. There's no point in me looking it up in my notes and writing this crap down. Now, so the 4 quantum numbers have names. They're called the principal quantum number, the orbital quantum number. Some textbooks call it the azimuthal quantum number. I generally do not refer to it that way. I do not believe you'd see it that way on an exam. The magnetic quantum number and the spin quantum number. All right, we're going to take them one by one. The principal and the spin have the least to learn. Okay? And they're the basis for what we will spend the next few weeks doing. Yeah, spin. Azimuthal. It's just another name besides orbital. Some textbooks will call it azimuthal, some will call it orbital quantum number. I will call it orbital quantum number. Those of you who want to pursue something in science, you may have a professor who calls it azimuthal. Okay? All right, is everybody caught up?
oh my gosh.
So, the lab, these two quizzes, and what else are going to be grade books?
Don't know. I don't know. Stop worrying about it. Learn the content. Grades will come.
No. This is the opposite for me.
I know lab and the quiz we took on Friday with Facebook already.
Nothing is in the grade book from Friday.
Special weekend. So I.
I didn't leave Baptist almost 1 a.m. Friday. So if I'd had all that crap with me, I'd had plenty of time to grade. But unfortunately, it did not go with me.
Start trying because of my brain. Video in the car. Oh my God, we're going to.
All right, so we're going to start with the principal quantum number.
Because of my grades.
The labs I will probably grade, best guess, is Tuesday and Wednesday, simply because second or third and fourth period have a regular test and the benchmark, and y'all have a benchmark Wednesday. By the way, in case I forgot, pretty sure we talked about this last week, but last week's sort of a jumble at this point in my head. We have benchmarks Tuesday and Wednesday.
Jesus.
And ours is Wednesday because second period is Wednesday. We're a regular academic class, so we have one Wednesday.
So that's
45 questions.
Perfect.
Do it as a test or a quiz?
Perfect. Now.
Why would I count it as a quiz?
Why would you count it as a quiz?
Really?
Because there's nothing on it we haven't done.
Right.
There's nothing on it we haven't done. Y'all need to study for Wednesday.
Can you give us a review, please, Ms. Wall?
You just want to create a review?
Yes. And if we do it, it's extra credit.
Shut up. Huh?
On the bench, we're gonna have to do scientific notation.
Yes.
You mean significant digits?
Yeah, that.
Significant digits.
Yeah.
Significant digits.
Ms. Wall, you can get a review.
All right, principal quantum number. Yes, it's multiple choice.
Ms. Wall, is it on computer or paper?
Yes,
Is it on computer or paper?
it's on paper.
What is dash in?
That's a symbol.
These.
All right, now you're gonna get tired of having to write out principal quantum number.
Yep.
And so we're gonna use symbols. Okay. So the principal quantum number has a symbol. It's N. So let's say tomorrow I had a quiz. Let's just say I did. And I said, what's the symbol of the principal quantum number? Usually it will tell me it's N. And if I said, what does it tell us? You should be able to tell me that it tells me the what?
Size of energy level.
Okay. It tells me two things. It tells me how big it is, it's the size, and it tells me the energy level. Okay.
Why is it N?
So, if I say N equals 1, you should be able to tell me what?
1 is the size and energy level.
It's the first energy level.
Oh.
If I said N equals 3, you would be able to tell me what?
The third energy.
No. If I said N equals 5, you'd be able to tell me what? It's the fifth energy level. You got the idea?
Yeah.
All right. Now, how does it tell us the size? All right. Well, remember those Bohr models we just drew?
Yeah.
Even though they're not technically correct, I can't draw a probability. All right. That would be 1 energy level. This would be 3 energy levels. Who would be bigger? 1 energy level or one with 3 energy levels?
3.
And if I drew one with 5, that's right. It'd be even bigger. Everybody got the idea?
Yeah.
So this would be clearly bigger than one with 1.
So it's just basically how many rings are there?
Yes.
So bigger,
The more energy levels, the bigger you are. Okay? So, So we'll write down what Linda said. More energy levels equals bigger. All right. So the last thing we need to write for this one is how many energy levels are we going to have? Okay. The values for N are generally going to be, here, let me do it this way or poor Caleb will never be able to see. All right. Are generally going to be, no, I'm going to have to leave it the other way so I can do it this way. Generally going to have to be 1 through 7. Okay? Now, we only have 1 through 7 because we only have enough elements on the periodic table to fill 7 periods. Now, if any more elements are discovered, then we'll go to 1 through 8. So, it could be any whole number. But because we only have elements in 7 periods, we're only using 1 through 7. Okay? Questions about the principal quantum number N?
Why is it?
That's what they assigned it. Didn't ask me my opinion.
That's stupid.
It's actually based on spectral lines names in the line spectrums.
Hey, there's a blue star on this desk. I'm just letting you know I didn't write it.
It's okay. Periodically, I just go through and wipe them off with wipes. I just haven't done it lately.
This ain't coming off.
All right. So, second quantum number is called the orbital quantum number. It's given the symbol L.
Why?
I don't know. I don't remember those names. It's 30 years old in my brain. All right. Now, it tells.
Why is you put the breast against just write
That's
a curse. That's a curse.
It's a cursive L. All right. It tells sublevel and shape.
Doesn't matter if it's an uppercase or lowercase.
It's generally going to be lowercase. All right.
Is that an L?
It's an L. It's a cursive L.
So will it always look like that?
It'll look like a lowercase L or italicized on the test. It will not be an I, which is why I didn't write it that way.
And I thought.
All right. It tells sublevel and shape. Now, so if there was a quiz tomorrow and I asked you the names, the second name is what?
Orbital.
What's its symbol?
L.
What does it tell us?
Sublevel and shape.
Okay. Just asking. I don't want to hear that I didn't tell you what was on the quiz. Now. All right. The number of energy levels tells the number, let me say this, equals the number of sublevels. Okay, the number of energy levels equals our number of sublevels. So, what are these sublevels going to be called? Nope, they got names.
I have to write that simple right. That's just confusing.
You're going to use it in a minute. All right, the sublevels names are S, P, D, and F.
This is the most random stuff.
Okay.
It's not random, just write it down. We haven't even got to the stuff that's confusing yet. It gets much worse.
Okay, give me a second.
Yeah, like, I was at my periodic table and started writing stuff, like, and she was like, you gotta do this and find this later on, and I was like,
Okay? So, if N equals 1, we want to find the number of sublevels and give them a name. So, if N equals 1, we're in which energy level? We're in the first energy level. This is why I wrote this in red. If we're in the first energy level, it tells us the number of sublevels. How many sublevels are we allowed? Number of energy levels means we get how many sublevels? 1. Everybody with me on why I wrote that? Okay? It means we get 1 sublevel. We want to name that 1 sublevel. Okay? Now, the first sublevel is S. They have to be in this order. If I ask you the quantum numbers, I don't care if you know them in order. The sublevels have to be named in the order S, P, D, F. So we name it S, but it needs something else. There are many S sublevels. Okay? So what energy level is S in?
1.
So we put 1 in front of it, and its name is 1S. Okay?
So the orbital number would be 1s.
Yep. So if n equals 2, let's do 3. If n equals 3, what energy level are we in?
It's 3s.
We're in the 3rd energy level. All right. How many sublevels do we have?
3.
There are 3 sublevels. So this time we have how many names?
3.
We have 3. We're going to name all 3 of them. We're not just going to name one of them.
What?
All right. If we have 3 energy levels, what do we write in red up here? The number of the energy level equals the number of the sublevels. So we got to name all 3 sublevels. So what are the first 3 sublevels named? So we have an S, we have a P, we have a D. Now again, what do we put on the front of them? Because there will be many S, P's, and D's. So they're where? They're in the 3rd energy level. So we put a 3 on the front of all of them. So we know they're in the 3rd energy level. And they're 3S, they're 3P, and they're 3D. You with me? That's where we're going next. If n equals 5, where are we at? We're in the 5th energy level, right? We're in the 5th energy level. How many sublevels do we get? We get 5 sublevels. We already talked about that. Y'all be patient. All right. So how many sublevels do we have? We have 5. Do we have enough names? No. Now, so we have S, P, D, F, and some unknown dude we're not going to name. Okay? We're not going to name him. So 5, 5, 5, and 5. So we put 5s on everybody. And the other guy, he gets no name. Okay? You don't even have to worry about the question mark. There would be 5 sublevels. We would not name the 5th sublevel for the same reason that if I went back here and I told you, nope, too far, but I told you that our values only go 1 to 7, we have no need to worry about naming another sublevel because we just don't have enough elements on the periodic table. Okay? We don't need another sublevel because we don't have enough elements to worry about anybody needing another sublevel.
If you were to ask something like that, would be like a trick question.
I would not ask you that. Okay? Questions? Now, that was the sublevel part. If we go back to what I told you about the orbital quantum number, I also told us what? Have I told you anything about shape yet? We got to learn shape.
They're round.
They're not round. All of them have a different shape. All right, so the S sublevel.
Wait, are we not doing 40?
No, because we're still on orbital.
So this is like a whole different thing.
This is the second part. All we talked about was the sublevel piece. The orbital quantum number also tells shape. Okay? So the S sublevel.
That's what it actually looks like.
So we got grass in here too.
What?
Yeah. Has a sphere for a shape. Now, yes, you got to draw it. Yes, you have to know. No, you don't have to know the shape. You can get those questions wrong. I have no issues with marking things wrong.
Wait, so like it's always gonna be sphere?
Yes.
Okay. That's what meaning.
So wait.
Why do we draw a graph to
They
make
go.
say it was a sphere?
Because it's going to go to the next quantum number with orientations.
But why is it? Why did you stop? Why did you stop 3?
You know, for once, I would just like for y'all to write it down instead of questioning constantly. Because believe it or not, it leads into the next quantum number. And I didn't just arbitrarily decide to have you copy this down just for the you know what of it. Okay? Just write it down. It goes into the next quantum number.
We're gonna be. We don't care.
Funny you should say that about this. Peanut coming back up. What do you suppose the shape of this looks like? Yeah. Nah, that's not what it's called, P. Ah. So when you look at this one,
We didn't think of it like that though.
you could. What's different about these three, since you're all tied up in why I drew it on a graph? They're turned. Say that again, Hallie. Yes, so this one has names that you have to know. This one's called the PX, this one's called the PY, and this one's called the PZ, which is why I told you had to draw the graphs, because would I ask you the name of those P sublevels? Or P orbitals, as we're going to learn their names are called. Yes, I would, which is why I asked you to draw them. Now, these can be called peanut, dumbbell, or two lobe. Any of those would be fine. You okay over there? Now, the others, you do not have to know the names for because they're much more complex to draw. I will attempt to draw D. F, I can't even make a stab at. Now,
Is it Z-Lobe or 2?
2. See the way I drew the Z's?
Is it like clover?
Yeah, it looks like that. Most of the D's look that way, except for one that's got this weird, like, ringing thing around it. But most of them look like that.
So kind of like a butterfly.
Sort of. All right, and it's referred to as four-lobed. Now, the biggest thing to notice about D is it has how many different ways to draw it or orient it? 5. Now, F, I can't draw it all. It's got so many offshoots and rings that I can't even make an attempt at F. You can look it up online. It's not hard to see if you really want to see it, but I cannot draw it.
Miss Wall, for the peanut dumbbell or two-lobe, does that go with like PX, PY?
No, you can call it any of those 3 names. It does not go to any particular one. Now, if you notice when you were drawing them, how many different ways could you draw S? 1. How many different ways could you draw P?
3.
And D?
Or like
5.
Wait,
And F.
numbers.
So do you notice a pi?
Odd numbers.
1, 3, 5, 7. They all
9,
increase by what?
11.
2. So if there was another sublevel, the next sublevel would have how many? 9. Okay?
So you mentally the one that you want?
I did, because I can't draw it.
Oh.
Okay. Now, its name, if I could draw it, would be a flower. You can look it up.
Clock.
What?
Picture clock.
If you would like to, feel free.
I remember this.
It just really almost made me want to cry when I thought it was 10:15. I was like, there is no way.
It's 11:15.
I feel like I'm at work.
Oh, we.
Anybody got you on camera?
One time I was at work, Miss Wall.
All right, does everybody have it?
Yeah.
Hurry up.
One time I was at work, Miss Wall, and our step ladder isn't the most reliable. So I was getting cups from like above it, and then here's our soda machine. The thing folded, and I fell into the soda machine. It hurt so bad. But it was really funny. It's the exact time.
Yeah, it's like 11.
11:14.
So moving like 11:15.
Yeah, one number up.
All right, does everybody have it? It doesn't matter what it's set at. I'll look at my watch.
Well, we
See if you can get the hole on the nail, so my clock does not crash. Fabulous.
I'm just wrong like that.
Try not to fall. All right.
I'd sue. Who would you sue?
We're still on this. It's nothing compared to yours.
We're still on orbital.
Now, they're not called the quantum letters. They're called the quantum numbers. So we have to assign numbers to the sublevels. We assign pictures to them and shapes, and we talked about what their names were, but we haven't assigned them a number yet. So we have to give them numbers. All right, so the S sublevel is assigned a 0. The P sublevel is assigned a 1. D is a 2, and F is a 3. Yeah?
So like the S, P, D, and F, they obviously stand for like sphere, peanut, flower, right? So what is the D?
They actually don't, but if you want to remember them that way, that's okay. Yeah. But she was trying to make the letters of the sublevel that
Science
shape.
is talking about, oh, do you see the new peanut of the sublevel?
Okay?
Think of D as double, because it's double circle. There you go, Joyce.
She said it was.
Doesn't matter, like,
I have no idea.
So think of Joyce, think of it as double, because it's 4.
Alright. So, that's an electron's address that I just wrote up there to the right. Okay? You have an address. Alright? Most of you have a number, a street address, a city, a state, and a zip code. Alright? Now, this would be an electron's address. So far, we've done the first 2 numbers. Alright? We've done N and L. So, what does N tell us?
The level and.
What level? Okay, so we know N equals the energy level, which is which energy level based on this address? So we're in the 3rd energy level. Or in your heads, based on what y'all can picture, I'm just going to write ring under there to give you a visual to attach it to. Okay, it's not technically a ring, but it's a visual for you. All right, so for L. All right, what does L tell y'all?
Sublevel.
Okay, L is the sublevel. Now, again, we gave them numbers. That's what this is for. So what sublevel do we know it's in? Okay, that's the most common mistake, Nylasia. It's really easy to say S is 1, P is 2, D is 3, F is 4. You've got to remember that S starts at what? So 1 is a P. So we know it's the P sublevel, and it would be one that is a shaped like that. Okay, it's a peanut. That's what we know based on the address. That's what we've done thus far. Okay, you could even tell me that it's a 3P based on what we've done. That's what we know. We haven't done the 0 and the +1/2.
Did anyone else just make Quizlets for fun?
No.
So will we ever use that? Like, I'm a little off.
Like in the West.
Are we going to use it? Yes. We're going to learn how to write electron configurations and orbital notations late in the week. Thursday and Friday. Okay? All right. Everybody? Okay so far? Or at least as good as you could be at the moment.
Yes.
Those of you who are completely lost, hopefully by the end of tomorrow, I'll have you caught up.
Yay! Which means we should have a quiz since we're confused.
Yeah, because the girl lost now.
Is this another?
All right. Magnetic quantum number M. All right. Magnetic quantum number M tells two things.
Oh, it's an M. Good.
Okay? It tells orientation in space, or it tells the number of orbitals. Now, notice this time I gave you an or, not an and. Some people prefer to learn this as an or. Some people like to learn it as the number of orbitals. Some people prefer to learn it as orientation in space. I don't care which way you learn it. It does not matter to me.
Which way you teach it?
Teach it both. Okay? Now, this is why I made you write down all those dumb pictures that you were moaning about.
Right.
All right? So, how many different ways did we draw the S sublevel?
One.
Because there is one orientation or orbital. All right? How many different ways did we draw the P sublevel? Now, for those of you who are like, I don't get it. These are orientations or orbitals. What happened to my X and Z there? All right. 1, 2, 3. That's where it comes from. All right. So there's 3 orientations or orbitals. So how many did D have? 5. And the F I couldn't draw had how many? 7. And if we were to have a 5th sublevel, let's just call him X. X would have how many orientations or orbitals? 9. Would have 9. Okay? Now, if I go back for a moment, how many electrons do you think this orbital can hold?
A lot.
A little more than 1.
2.
Can hold 2. Okay? That's just how many it can hold. It don't hold much for electrons. All right? So, each... Why on earth is that so wide? All right? Each orbital holds
I'd make those so pretty with all the colors.
2 electrons. Okay? Each orbital can hold 2 electrons. So how many electrons can fit in the S sublevel?
2.
Okay? How many can go in the P sublevel then?
6.
How many can go in D? And in F?
So you basically just multiply by 4.
Correct.
Okay, so we add 2 and then.
Do we have a worksheet tonight?
Yep. Yep.
Is it gonna be great?
Only if I check homework.
Well, can you check homework? We haven't had homework check.
Yeah.
Y'all sound like Annabelle again. All right.
Oh.
So, the hard part of the magnetic quantum number.
Wait a second. Go back to the wall. Actually, Kevin's up.
All right.
Why am I going back?
No, it's all left behind.
Are you serious, Kevin? I just blocked you.
Alright, you need 2 seconds to word.
All right. So, just like the orbital quantum number, the sublevels had to have numbers attached to them. Okay?
Oh, your room.
These things have to have numbers attached to them. Okay? Have to have numbers. This is usually where people run off the rails.
I'm already off the rails.
Listen, quit making side comments. Just listen.
All right? M is equal to minus L to positive L. Okay? All right, so what was the number we assigned to the S sublevel? Listen to Nylasia. She said we said L was equal to 0. Okay? So if we plug into the formula, what is minus 0 to positive 0?
0.
So M is 0. Now, that's how many numbers? That's only one number, right? We should only have one number because S only has how many of these doodads? So that one number goes to that one set of X, Y, Z axes. So that is going to have a value of 0. Now, if we do P, P's value was what? Okay, it was L equals, change colors. It was L equals 1. All right, so if we plug in the minus L to positive L, what do we have? Minus 1 to positive 1. You're on the number line, people. What numbers do I have?
0. Oh, we can't. I can make a number line account.
Make a number line and count.
2 numbers apart.
0. 3.
Right?
It's 2. Oh, I thought. Okay.
It's gonna be 2.
No. Yeah.
I don't know where y'all are getting to.
Oh,
But
3.
What are you talking about?
Are you counting
Are we counting the numbers or like how many spaces there are?
Wait.
3.
That's the answer I want.
Oh.
I don't know. That's how I'm like, I don't know what y'all doing with this 2 thing.
Wait, I'm confused. How do you get 3? Like, I know that there's 3 numbers, but like on the first one,
That's cheating.
Wait,
It's legal.
Why don't
I
you
thought she meant for us to count
do it like
places.
that?
Yeah, no. That's not what I want. No. I just wanted the numbers.
Okay, that's all.
Okay, I get what y'all are saying now. That's why I'm like, we're not on the same page. Yeah. So I got 3 numbers because if you look at the P sublevel, how many different pictures did I draw? 3. So this one would be -1, that one would be 0, and this one would be +1.
So D would have 5 and F would have 7.
Yes. So if we turned around and did this with D, D's number would be what? 2. So if I went M equals -2 to +2, what numbers would I get here? Okay, so that's 5 numbers because I have how many of these lovely X, Y, Z axes this time? I have 5. So this one would be -2, -1, 0, 1, and 2. You see the pattern?
Don't talk about
Wait.
So the last one would be L equals 3. So M would be what? Okay, so -3, -2, -1, 0, 1, 2, and 3, because that's 7 numbers, because we have 7 of these axes this time. Oops, I think I drew 8. Yep. You have the spin quantum number left. It's the easiest of all of them.
Alright.
We're down to the 10-minute mark. You want to burn all fast in 10 minutes?
And then I have to go, so I've been waiting for us to finish.
If you don't just hold it.
I was gonna say I'd hold it. All right, everybody there?
Yes.
All right, so the last quantum number, the easiest one of all. So if I ask this on the quiz tomorrow, nobody better get it wrong.
I'm gonna get it wrong.
Okay, so only Annabelle's getting it wrong.
I didn't say I was getting it wrong. Thank you.
Who said they were getting it wrong then?
Faith.
All right, Faith's getting it wrong. So the spin quantum number, any guesses as to the symbol? It's S. Now, so you got to keep it straight. If I say S quantum number, I mean this. If I say S sublevel, I mean the S sublevel we've been talking about, not this. All right, so the spin quantum number tells the spin of the electron. Now, how many electrons were in each orbital?
1. Depends on the number.
How many electrons were in each orbital?
2, 6, and 14. 2. Oh.
Look up there in the blue.
2.
2. All right, so each orbital holds 2 electrons max. All right, so if they hold 2 electrons max, do they spin in the same direction or in opposite directions? Okay. The electrons spin in opposite directions. All right. Clockwise and counter clockwise. Now, because they spin in opposite directions, we give them numbers to represent opposites. So their values are plus and minus 1/2. Okay? Now, it doesn't matter which one is the plus and which one is the minus 1/2. Okay? We don't say clockwise is plus and counterclockwise is minus. It's just the plus and minus 1/2 is to represent one's one direction and one is the other direction. Okay? You with me? Yes or no?
Yeah.
Think you can try a couple questions?
No.
I'll do it anyway.
Do it.
Everybody got what they want?
No. Yes.
So tired.
No, I It started talking about the baby, so like, and I started talking about the grades. They talk about what? We're not coming to school Friday, we're leaving at like 5 o'clock in the morning to go to Maybe like 75 from there.
1 through 3 are straightforward What did the note say? All right, 1 through 3 are straightforward. What did the note
And I
say?
want the quiz to look like this.
4, 5, and 6. I already told you what's on the quiz.
What's on the quiz?
She's been telling us.
I've been telling y'all the whole time. Yes, I have. If you were listening to me, I asked you what the quiz question was and what the answer was. If you were listening to me,
Now go watch the video.
I'm not telling you again. All right, but 1 through 3 is just what are the answers out of the note. 4, 5, and 6 ask you to think.
I don't want to.
Well, if you don't want to think on those, you're in deep doo-doo on the rest of what you got to be able to apply.
Oh, man. Right, Chris.
All right, while y'all are trying those, I'm going to hand out homework.
Oh my God. Are you gonna check it this time?
No, what, Karen?
No, you
I was like, you didn't check it.
I don't get second part.
This is the one I really need to check. Because if you're not studying and doing any homework, it's pretty obvious on this.
That's where you're.
I don't know what to tell you.
No.
Do they have a blocking pen?
Like,
Oh, it's
Yeah, don't worry. I'm taking mine off the bathroom.
I'm saying your mom.
What do we only have to do?
Yeah.
It's a nice
This is the second one. What is the second one called? Quick. S&P, 2 blood levels. I don't know.
What's the
Next
answer
one,
to number two?
Something like that.
Okay, yeah.
The orbitals.
I just know that three,
It was too long.
Me too. What questions are we doing on homework?
All.
Are you insane?
I don't know.
I got this in like 8 lessons on that.
What's wrong with her? Got no break.
Yay!
Alright. So if we look at number 1, which quantum number tells shape?
Orbital.
Orbital. How many sublevels does n equals 2 have?
2.
What are their names?
SP.
What do we put in front of the S and P? 2s and 2p. Alright, how many electrons can a d sublevel hold? D can hold 10. F was 14. Alright, how many electrons can n equals 3 hold?
6. Wait, what? Hold on. Yeah, that's whatever.
18.
How?
Oh, wait, do you know
N
that?
equals 3
I
is
wrote
an
that.
energy level. So how many sublevels are in n equals 3? There's 3 sublevels. What are their names? 3s, 3p, and 3d. You have to add all the sublevels electrons together.
Really close.
Oh.
We really not doing squeeze.
Oh, how many electrons are in S?
9 times 2.
I don't know what this is.
So now
So
we'll
3 S3,
No.
S3, and then.
But you want-
What?
So now we'll add it and then we'll.
So for those of you who are on that one, for n equals 3, how many sublevels are there?
3.
There are 3 sublevels. There are 3s, 3p, and 3d.
Right.
How many electrons can s hold?
2.
How many electrons can p hold?
2.
6,
How many can d hold?
10, 14.
F was 14. You don't have an F up here.
Oh.
Add those together, and that's how you get 18. Okay? Now, we'll do the remaining ones tomorrow. On your homework, do all of those.
Okay, if we added 3 together, then times it by 2, so I know.
If you add 4 ones together, the 1, 3, 5, and then multiply by 2, yeah. You can. Remember, if you have missing work, I will be here today. Do not, if you can, do not wait to the last minute.